All right, so this is going to be where you're going to write down all of the stuff that you need to look and know, and some small forms. Quadratics can be rewritten in 3 forms. These are the 3 forms. It's called standard form, and sometimes that's equal to 0 rather than. So if you want to, and it also can be in the other order. So if you want to write ax squared plus bx plus c equals 0, sometimes it comes to you like that, and that's still in standard form. Again, the vertex form, it might be written a and then parentheses x minus h squared plus k. They might have it equal to 0. And the same thing is true for this one. They might have the factors, and that might be set equal to 0. As a matter of fact, a lot of the times when we're working with this, that is the first thing we're going to do, is set it equal to 0. Now, there are ways to see these quadratics that are not in any form whatsoever. Like, for example, it might be, I might show you this quadratic. X minus 2 squared equals 16. See, that's not in any form. It's almost in vertex form, but it's not equal to 0, so it's not really considered standard form, vertex form, or factored form, but it's pretty close to vertex form. I've got an asterisk right here by vertex form because this is the form that we're going to look at to describe the transformations. So sometimes they call this the transformation form, but not always. So you could totally write the word transformation right there. It does show you your transformations. Okay, so what can you look at an equation and tell about it? You can always look at an equation and tell how it opens. You can look at an equation and tell if it's going to open up or open down. So I'm going to put a little, this is what I mean when I say it opens up. This is what I mean when I say it opens down. Those are the 2 different ways that a parabola can open. Now remember, I did talk about opening right, opening left, but those are not functions, and so we're not looking at those right now. Those are in the section where we study conics. So it's either going to open up or down right now. And the way that you can tell by looking at an equation is by looking at the sign of A. The sign of A. When you have a positive A, it's opening up. When you have a negative A, it's opening down. And that's true on every single form. A positive A means it's opening up. A negative A means it's opening down. Positive A means it's opening up. A negative A, this negative A right here, means it's opening down. So all you got to do is look at the equation and tell me if it opens up or down. So all we've done so far is learn how to look at an equation, and I've given you 3 examples right here. This one's in standard form, this one's in vertex form, and this one is in factored form. And in each one of those, we should be able to look at the A. And in this problem, the A is the number in front of the x squared. See right here, A is in front of x squared. So there's my x squared. What's the number in front? My A is -1. So since we look at this and see that A is -1, we know that this parabola is opening down. Now you can say, you can write it out in words. You can say the parabola opens down. You can say the A is negative, so it opens down. You can draw me a picture. Just depending on how I ask you would depend on how you answer. But here, drawing a picture is fine. Okay, so for vertex form, the A is the number in front of the parentheses that's being squared. Here's the parentheses that's being squared. The number in front is a 2. It's a positive 2, so we know that that means that the parabola is opening up. Okay, because the A is a positive number. The A is a positive number. This is a positive number, so we know it's going to open up. Here, the A is the number that's in front of both sets of parentheses. Here's the parentheses, and there's not a number in front. So what does that mean? That means the A value is 1. A is 1, but it's a positive 1. So that means that our parabola is opening up. So that's one of the things that you can just look at so far and tell me how the parabola is opening depending on whether the a is positive or negative. The next thing we're going to do for the standard form, the next piece of look and know information is the y-intercept. The y-intercept for standard form is always that constant. That's what that C stands for, by the way. C stands for constant. The y-intercept is always going to be 0C. Whatever the C value is, that's what your constant is going to be. So on this example down here, since this is the standard form, I can look at this and see what the y-intercept is. This is my value of C right here. This number is my C. So I know my y-intercept. My y-intercept is going to be the number 0, -3. And if you're plotting that, and you should, then we know that my y-intercept is going to be right there at 0, -3. The axis of symmetry, it's not look and know information, but it is calculate. It's a small calculation. And the small calculation is going to involve, let me change pens again. The small calculation is going to involve, you're going to find, it's going to be x equals, because it's going to be a vertical line, and it's going to be x equals, we're going to find -b over 2a. So you're going to have to know the values of b, and you're going to have to know the values of a. So it might be helpful anytime you're working with standard form. I think it's always helpful to write your values of A, B, and C down. A is -1, B is 2, and C is -3. Be sure you get your correct signs. A is -1, B is 2, and C is -3. So when I'm calculating my axis of symmetry, I know it's going to be x equals, and then I've got to do this calculation. The calculation is -b, so I'm going to look, since it says -b, I'm going to look at the b value, it's 2, and this negative sign, the negative sign right here, is telling me to look at this b, and it's telling me to whatever sign is written down right there. When I write it down over here, I'm going to change the sign. So I see a +2, -b says write down a -2. If I saw a -2, I would write down a +2. So whatever the b is, you change the sign when you write it down. Now the rest of the formula says on the for the bottom number, I've got to take the value of a and multiply it times 2. Well, the value of a in this problem right here, a is equal to -1. So what am I going to plug in right here? I'm going to plug in -1. Okay, so I've got to do a little calculation right here. I have -2 on top, and I have 2 times -1 on bottom. That means I'm going to have -2. That means that when I divide -2 divided by -2, I'm going to get +1. So my axis of symmetry is going to be the equation x equals 1. That means that my axis of symmetry is that dotted line that's right there. Now, you remember the mirror image? Remember my y-intercept? I have my y-intercept graphed right here at 0, 3. So that's 1 unit away from the axis of symmetry. I can go to the other side and graph that mirror image right there. So this is the mirror image of the y-intercept. This one is the y-intercept. This is the mirror image. Now the last thing I'm going to find is the vertex. Now the vertex I already know is the first value is -b over 2a. Now to find out what the y value is, I've got to take this -b over 2a and plug it into the equation. So my axis of symmetry is x equals 1. I'm going to take that 1 and I'm going to plug it in. Negative, I'm writing down this the symbol that's in front of the x right there. I wrote that down again, negative. And then in parentheses, that's where my x goes, plus 2 times x minus 3. You see how I'm going to take this number right here, I'm going to plug it in right there and plug it in right there. So I'm going to put 1 right there and 1 right there. So be careful right here because this is kind of tricky. 1 squared means 1 times 1. The answer to that is 1. Then I have this negative sign right here. So that ends up being negative 1 plus 2, because 2 times 1 is 2, minus 3. I end up with a negative 4, sorry, and a positive 2. Put those together and I get a negative 2. So that means that my vertex is right there. So my vertex for this one, my vertex, I found it to be 1, negative 2. So here's how we write, plug it in. We're going to write f of negative b over 2a. This is just this notation right here. This f parentheses negative b over 2a is just my way of saying plug it in. Plug it in the equation for x. We know all about plug and chug. So that's what the vertex is. The vertex is a plug and chug problem. We do this small calculation, we get a value, and then we plug it in to get the y value. So I'm going to connect these dots the best I can to show what my parabola looks like based on the information, the look and know information, how it opens, the y-intercept by looking at the C, the small calculation by finding the axis of symmetry, and then plugging it in to find the y value of the vertex. So I got 3 points. 3 points is what I always need to graph a parabola. In this case, I got the vertex, the y-intercept, and the mirror image of the y-intercept.